Hello, this will be the video for the first section from Chapter 2. In Chapter 2, we're going to be talking about functions, equations, and graphs, and how these are all related to each other. And Section 2 is about relations and functions. Right, these words you've probably heard before, but maybe you don't know the exact definition. We're going to get to that. So an essential understanding that we're building towards is when we have a pairing of items from two sets. That's especially special or interesting to us if every item from one set pairs with exactly one item from the second set. And we'll get more detail on that in just a moment. So let's start with a definition here for relation. A relation is a set of pairs, there's a little typo there, of input and output values. So we just have some sense of, I start with one thing, I get another thing. I start with one thing, I get another thing. And when I collect all those together as pairs, I think of that as a relation. It's a very broad concept. And we can represent a relation in one of four different ways. So let's look at an example. I can just give a list of ordered pairs. So maybe I can say I want 1 paired with 3, and I also want 1 paired with 5. I want 2 paired with 2. I want 3 paired with 0 and also paired with 5. I want 4 paired with 1, and I want 5 also paired with 1. These are ordered pairs. The order matters. To say that I have 1 paired with 3 is not the same as saying I have 3 paired with 1. So I can just list what are all of the pairs. Input, output, input, output, input, output, etc. I can represent this with a mapping diagram. So in the mapping diagram, I can imagine that over here I have all of my different inputs. And we'll learn a more technical word for that in just a second. Here's 1. 1 is sometimes an input. Here's 2. That's sometimes an input. Here's 3, here's 4, here's 5. Just kind of putting them all together in a blob. And then here are all my different output. The outputs that show up are 3, and 5, and 2, and 0, and 1. And then I can just kind of show what input goes to what output. 1 goes to 3, I map that like so. And I use the arrow to indicate I'm going from input to output. 1 also goes to 5. 2 goes to 2. 3 goes to 0. 3 also goes to 5. 4 goes to 1. And 5 goes to 1. This diagram is a little bit confusing looking, but if you look at one arrow at a time, you do understand what's the input and what's the output. We can just give a table of values. When we do it in table form, we usually call the first number X and the second number Y. And I'm just going to repeat everything I saw before, but instead of writing them as ordered pairs, I'm just going to write one number on the left, one number on the right. While I'm talking about ordered pairs, I just want to emphasize here, the parentheses at the beginning and end of an ordered pair are not optional. When we write an ordered pair, it is parenthesis, and then a number, and then a comma, and then a number, and then a parenthesis. Some students leave out those parentheses. That is not correct. And then the final way we might want to represent a relation is with a graph. So we'll imagine here's our x-axis. Here's our y-axis. I'm dealing with numbers from 0 through 5. So 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. And for each one of these ordered pairs, I'm just going to plot the corresponding point. So 1, 3 is like that. X is 1 and Y is 3. 1, 5 is like that. 2, 2. 3, 0 means X is 3 and Y is 0. 4, 1. And 5, 1. So depending upon the context, any one of these four things might be the way we talk about a relation. Or we might actually just describe it in words or using mathematical notation. Right, that's what's coming up here. Since there were just a few ordered pairs, another typo there, yikes, it was easy enough to list all of them. But sometimes we want to describe a relation. So here's a relation. right? I don't even give it a name, but I'm going to say the ordered pair xy is in the relation if and only if x is equal to y minus 3. So for this one, let's just list some elements, right? X has to be y minus 3. So if I had, for example, 2 comma 5, at 2 is equal to 5 minus 3, so that's okay. I could have 4 comma 7. I could have 11 comma 14. And we would notice that this list goes on forever. You can keep thinking of examples of two numbers where x is 3 less than y. So we're never going to be able to list all of them, in which case it's nice to have this description. I have described what these all have in common because it's impossible to list all of them. I could have a relation among people. These don't have to be strictly mathematical. I could say the ordered pair AB is in the relation if and only if A, person A, is the parent of person B. So for example, I could say Joan Friel, my mother, is the parent of me, Patrick Friel. And I could list all of the combinations of parents and children in the world. There are billions of them, so I don't want to list them. I want to describe it. And you can take a moment and just think of something that you could describe as a relation. Just a way of pairing things up or people up or objects up in a way that you can describe. There's so many examples. I'm not going to go through any right now. If you're doing this on your own and you're curious, check in with me. Probably you have a good example. So as we mentioned before, the first element in an ordered pair, we think of that as input, right? That's what we're starting with. The second element is output. That's what we end with. So we're going to have some definitions here. So the domain of a relation, we're defining the word domain, is the set of all of the input values. So I would collect together all of the things that show up somewhere as that first entry, as that input value. And then the range is all of the output values. So domain is input values. It's the set of all of them. Range is the set of all output values. And I just want to give you a little warning here. Very often, we call the input X and we call the output Y. So because of that, a lot of people say just like, oh, domain is all of the X's, range is all of the Y's. That's fine if your input is called X and your output is called Y. But sometimes that's not what they're called. And I don't want you to get confused. So I strongly recommend you actually learn this by just domain is all of the input values, whatever input is called. Range is all of the output values, whatever output is called. So let's practice with the examples we saw already. There are 3 examples already in the notes. Right, so here's this first one that I did in a lot of ways. So I'm going to add to this diagram. So for this example, the domain would be the collection of all of the input values that showed up. It was 1, 2, 3, 4, 5. Formally, when we collect things together in a set, we put them together in curly brackets like that. Don't really worry about the notation. As long as you can communicate to me that you understand what's in the domain, I'm not going to get super picky. And the range would be all of the output values we get. I'll try to do these in numerical order so it makes more sense. 0 is in there as an output value. 1 is there as an output value. 2 is there as an output value. 3 is there as an output value. 4 is not, and 5 is. So that's the domain and range for this particular relation. For this example here, it's with numbers. X is y minus 3. Right? If you think about it, every single number could be the input. Whatever number you're thinking of, is that 3 less than some other number? Yeah. So anything could be in the domain. Every X is theoretically possible. We could just say the domain is all real numbers. Any number on the number line absolutely makes sense here. And the same for the range. any number you're thinking of theoretically could go second, right? 17.2, yeah, 17.2 could go there, and 14.2 could go in front of it. Same with domain. Pick your favorite number to be in the domain, 0.112, and 3.112 would go with it. So here, domain and range are all real numbers. For this one, the relation is that A is the parent of B. So this input has to be someone who is a parent. So the domain would be the set of all parents. But the range would be anyone who has a parent, and that would be the set of all people. Some people, their parents are deceased, but let's just say that we're counting deceased people as well. So, domain is all of the things that come first, all of the input values. Range is all of the things that come second, all of the output values. Okay, now we're going to continue just thinking about how ranges work a little bit. So, those two examples we had on the previous page. For the first one, and again, this first one basically said x, y is in there if x equals y minus 3. I want you to experiment with just picking some values of x. And in each case, I want to ask you, can you tell me with confidence exactly what y should be? So for example, if we start with x equals 4, do you know for sure what the corresponding y is? If you think about it, it has to be 7. If we start with -2, do I know the corresponding y value? Yeah, it has to be 1. If I start with 92.5, do I know what the corresponding y value is? It has to be 95.5. So what we're noticing here is each x is paired with one specific y value. But let's look at this other example. So it's more typos. So remember, for this one, we're saying A comma B being in there means A is a parent of B. Wait, is that the order I had? Let's just double check. A is a parent of B. So in this case, if I tell you the starting value, if I tell you who A is, do you know exactly who B is supposed to be? In some cases, maybe you do. In some cases, maybe not. Right? To use just the example again from my family. If A is Joan Friel, well, B could be me, Patrick Friel. But it could also be my sister, Bonnie Friel. So what we're noticing here is one input value gets paired up with multiple output values. Sometimes we have a relation where every input has a unique output. Sometimes we have a relation where, some inputs, maybe not all of them, but some inputs are paired up with more than one output. And generally speaking in mathematics, we're more interested in that first case, where there is a unique answer. So here's our definition. A function is a relation in which each element of the domain corresponds with exactly one element of the range. Kind of to rephrase this, each input value corresponds to one unique and specific output value. If I tell you what the input is, you know exactly what the output is. There's no guessing. We call that a function. So let's just practice a little bit. I have 4 relations here. And try to figure out which of these are functions. In which cases does the input predict exactly one output? So let's look at this first one. The ordered pair xy is in the relation if x is equal to y squared. So ask yourself, is it always true that if I tell you what x is, you know exactly what y is? Right, what if I tell you x is equal to 4? Well, then maybe y is equal to 2. But if you think about it, maybe y is equal to negative 2, because negative 2 squared is also equal to 4. So what we're seeing here is the input of 4 corresponds to 2 different output values. This is not a function. How about if the ordered pair xy is in the relation if y equals x squared plus x? So you can choose some examples. If x is equal to 2, then looking over here, we can actually calculate what y is. Right? It tells us exactly what rule to follow. If we're following exactly one rule, then it leads us to one specific answer. Right? I just do the arithmetic and I get 6. I don't get anything else. If x is equal to 5, I do the arithmetic and I get 30. I don't get anything else. If x is equal to negative 1, I do the arithmetic and I get 0. I don't get anything else. So this is a function. And what we're looking at here is what we call a function rule. It's telling us exactly what to do to the input in order to figure out the output. So it's telling us exactly what to do, so we know exactly what number we're going to get. Okay. For people, the ordered pair A comma B is in the relation if person B is a parent of person A. So be careful. This is the reverse of what I saw before. Obviously, gave before. Here, B is the parent of A. So if I start with a certain A, right? So again, I'll just use my example. If I am the input, who is the corresponding output? The corresponding output would be a parent of mine. So it could be my mother, or it could be my father. So this is not a function. One individual usually has more than one parent. So there's no uniqueness. When we say B is the parent of A, that's not always pointing at one specific individual. While here, if I say person B is the biological mother of person A, right, assuming that we define biological mother in a precise enough way, let's not worry about that too much, then that does point to one particular person. Right? If you ask someone who is their biological mother, as opposed to just who is your parent, there's a more specific answer to that. So this one is a function. We're about halfway through this section. Let's just pause the video here and I'll do the second half later.